Hello, good evening. My name is Yogendra Kumar and I'm a maths teacher at askIITians. Okay, so today we are going to do rational number chapter, rational numbers, okay, which you have weightage of 6 marks in your final exams, right? So we need to do this chapter in detail, okay? Uh, okay, I hope I am clear and loud enough, right? Okay. So we are going to do this chapter in which we need to learn. Okay, by the way, this chapter is there in your ninth grade also, which comes with the name number system, in which we are going to learn not only about rational numbers, we are going to learn about the irrational numbers also, right? So what is the basic idea here? Right now you learn about the rational numbers and then you learn all about other numbers also, irrational numbers also. By the way, like whatever numbers we have in maths, they can be divided into two categories. Okay, one is what rational, other one is what irrational. So right now we are going to focus on the rational numbers, right? So we need to see, these are the topics we are going to cover. Okay, so topics to be covered are what? Properties of rational numbers, closure property, commutative property, associativity, right? Commutativity, associativity. We need to see this. Negative of a number and reciprocal of a number. Pretty easy topics are there. You need to just listen to me carefully. If you listen to me carefully, you're going to remember it. Okay, no need to worry at all, right? Okay, so this is what we are going to do today, right? So what do we have? Actually, we have real numbers. We have real numbers. All the numbers which we have, okay, those are what? Real numbers. And those real numbers are divided into two categories: irrational numbers, the numbers which are like pi, e, root 2, root 3, cube root, and all like that. Okay, those are irrational numbers. Rational numbers are what? Those numbers which can be written in p by q form, and which we are going to learn in detail. Means all integers, whole numbers, natural numbers, okay, fractional numbers, decimal numbers. These all are what? Rational numbers we are going to learn, right? So we have here properties of okay, these properties we need to learn. So let's get started, right? Okay, so what is closure property, right? So when we add two rational numbers, okay, first of all, I think we should be having definition of rational numbers. So it is not given here. No need to worry. I'm going to add it here. Okay, what are rational numbers? We need to understand those first. Okay, so let me write down the definition of rational numbers. So numbers which can be written in, uh, or we can say real numbers. By the way, what are the other numbers other than real numbers? We have something called as imaginary numbers also, but that is right now you need to remember that there is no imaginary number. Okay, you're going to learn in 11th grade somewhere. Okay, which we come like, okay, root of -1, this kind of form. These are what? Imaginary numbers. But you don't worry at all about it. You need to just remember till 10th grade. You need to remember that there is no imaginary number, because this is just limited to one chapter only. Complex number is the concept which chapter name, okay, and that is the only chapter which will be using this. Okay, so that's all you need. It is limited to this much only, right? But yeah, that is also a pretty good topic, but you will need to learn later on only. So real numbers which can be written in p by q form, okay, where p and q both are integers and q is not equals to 0, because integer could be 0 also, but denominator cannot be 0. So this is what you need to remember. So rational numbers are those numbers which can be written in the p by q form. So here example I can give, like if I say zero point 0.1, it is what? Rational number. Why? Because 0.1 divided by 1, and we can write it 1 by 10. So this is what? P by q form. So it is what? It is a rational number. This is rational number, right? I'm just giving you the idea. You need to remember it. Okay, these are what rational numbers. We are going to learn, we are going to do operations on the rational numbers only, right? In the today's lecture, right? So I hope you are understanding this, right? Now see, we have a closure property. Two rational numbers, if we add, subtract, multiply, we get what? Rational number only. It will be producing a rational number. So rational number, as I said, okay, p by q form, this is p by q form. So can I add them? Yes, I'm getting p by q form only. So this is what, okay, we are getting a rational number only. If you subtract also, then also, if you multiply also, then also we are going to get a rational number. If we are multiplying rational number to rational number, or we are adding rational number to rational number, so this is what closure property we call it, right? The rational number, okay, you can say rational number here plus rational, okay, rational number and rational number, if we add, what are we going to get? Rational itself, right? This is what we need to remember, right? If we add, subtract, or like that, okay, we do any operation on rational number like that, so we are going to get rational numbers only, right? So this is what you need to remember. I hope you are getting it, right? If you understand this, then let's go to next topic, okay, which is what? Commutative property on rational numbers. So what do we say? Rational numbers follows commutative property. Means what? Here commutative law, what it says, a plus b is going to give you, like a plus b is what? Same as b plus a, because it is not going to change any value. Same thing goes with the commutative law of multiplication. A into b is same as b into a. Not obviously this is not true. This is not true, right? You can understand. 2 minus 5, is it equals to 5 minus 2? No, right? This is not true. But for plus or product, it is true, right? Division also not. So commutative property, addition and multiplication, okay, that is what it follows, okay, but not the plus or minus, okay, like this. A plus or, sorry, minus or division, my bad, okay, minus or division will not follow it. Now associative property, what is it? Rational numbers follow associative property for addition and multiplication. So this is what you need to remember, right? What do we say here? Plus, if I am adding x, y, z plus, and then I'm adding to x, or I'm adding x and y and then adding to z, that is going to give you same result, right? So here for multiplication, what do we do? Same, yz you multiply, then multiply the result from yz to x. Or what do you do? Xy you multiply and then finally multiply to z. Same thing you're going to get. So associative property and commutative property on rational numbers is applicable in what operation? Addition and multiplication only. This is what you need to remember. But closure property is applicable for addition, subtraction, multiplication. For all these, we are going to see a closure property, right? So I hope it is clear. Let's move to next here on this question, right here. So what they say, show this by distributive property, right? So basically what we need to show that it is what? Okay, basically they what is asked in the question, that this distributive property is applicable on the rational numbers. This is what we need to show. This is the distributive property on rational numbers. So 1 by 2, if I multiply it to like 1 by 2 plus 1 by 4, first I do, and then multiply with 1 by 2, means if I do LHS 1 by 2 into, now here 1 by 2 plus 1 by 4, 1 upon 4. So what we are doing here, 1 upon 2 into, now here addition. So I hope you know this. We need to take the LCM here, right? Here I need to multiply 2 and 2 to take the LCM. So 2 plus 1 divided by 4. So what are we getting? 1 by 2 into 3 by 4, which is what? 3 divided by 8 we got. LHS is what this. Now RHS is what here? RHS is 1 by 2 into 1 by 2 and plus 1 by 2 into 1 by 4. So what do we have here? Now this is 1 by 4 and this is 1 by 8. You can see, right? It gets multiplied like that. So now here we need to make the LCM same. So 2 I need to multiply. Now LCM is same. So 3 divided by 8. So we got LHS is same as RHS. So means, what do we say here? Distributive property is applicable. Distributive property is applicable on rational numbers. So this is what we are going to say. Okay. Right. This is what they're telling here. Rational numbers are what? These are all rational numbers. And what are these? Irrational numbers. We have these all irrational numbers. Right. So I hope you're getting it. This is what you need to understand. Let's move on to, okay, this is what the proof shown here.